Hello, I am Chris, a program manager on the Universal Windows platform. I'm here today to talk to you about multitasking in the Fall Creators Update. When we talk about multitasking, we're talking about what scenarios involve your app going into the background or starting in the background in order to do some work on behalf of the user. Now, in the Fall Creators Update, we've enabled two paths for you so that you have a great amount of choice in your own implementation. You can either choose the single process model, or you can use the older multiple process model. We're going to go into a little bit about multitasking for your particular scenario and what the Fall Creators Update can do for you there, as well as going into persistent events and how a new feature called background task registration groups actually enables you to simplify the registration for background triggers. So the single process model, if you're not already familiar, enables you to write your entire app, all background activity, all foreground activity, in one single process. In this, you would activate your app in the background, whether it's going to be launched in the foreground or whether it's just handling a background trigger. And then you would be activated by either a launch, an activated, or background activated callback, and you would be running in the background for a very short period of time. At that point, you would get one of these new callbacks. You would be getting a leaving background callback if you're going to be moving into the foreground, and then you're visible. You're visible to your user doing whatever experience you need to be doing. Then, if the user were to minimize or to close your app, then you would receive an entered background callback. And depending on what kind of work you were doing at the time, either you would continue to run for a period of time in the background, or you would actually move into the suspended state, and so you would receive the suspending callback from that. Now, from suspended, you could either be terminated if the user did choose to close your app, or you could be resumed into the foreground if, say, you were minimized and then the user chose to bring you back up. Or you could even be resumed in the background if a new background trigger came in and said, hey, I have some work for you to do right now. Let's just keep you silently working in the background while your app is also available on the taskbar or present in some way to the user. So with the single process model, we've actually enabled a lot of great scenarios so that it's very easy for you to implement some very core functionality that users always want in their platform. One of those is background media playback. In order to enable background media playback in the single process model, all you have to do is add a capability to your manifest and then use all of the same Windows audio APIs that you would normally use. Audio graph, media player, anything that you would normally use in order to play any type of media would continue working now as you move into the background. So in that previous diagram, you would see, hey, I'm moving into the background. I'm going to receive an entered background callback. However, I'm going to still be able to play my media. And if you're streaming, you'll actually still be able to hold on to that network reference so that you can keep on streaming as long as you need to. Another scenario that users are constantly requesting and that we've made it easier for you to implement in the single process model is with background location tracking. This background location tracking is great for turn-by-turn navigation, for mapping type apps, or for fitness trackers. Now this is implemented using an extended execution session. And as you could see, you would use a location tracking extended execution reason with the extended execution session, and you would actually make a request for this. Now, during this request, you would check if the system said either you were approved or not approved. So you need to make sure to check this request result, and then if it turns out you are not approved, it's really important to go check your background access status. Now, background access status is available through the Background Execution Manager, and it mimics the user choice that is shown in the settings pages. So if a user were to choose to not allow your app to actually run in the background, you can check that using the background access status and inform the user that it was due to their choices that you're not currently able to run. It's really important to remember that you need to request this extended execution session in the foreground. So it's best to request it when either the user has chosen to start a location tracking type of action, or right at the beginning of when your app first launches into the foreground. Another common scenario that users really expect, particularly out of desktop applications, is for productivity apps to be able to compile a project or to put together a set of media assets in order to create a finished product. And we've enabled all digital audio workstations and all other of these productivity apps to be able to do this using an extended execution as well. Now this is the unspecified extended execution reason, and in the same way that you would handle that request result from location tracking, you would also want to make sure to handle that here, as well as the revoked event. Now, extended execution unspecified is a battery-aware type of extended execution, which means that if you're on a device that has a battery and is not currently plugged into power, it's considered to be a battery-constrained device. And so you'll only get a finite amount of time, around 10 minutes or so, for your extended execution to run. It's really important that you inform the user of this and then allow them to make a choice to actually extend the lifetime of your app in the background. So, in this case, background access status comes into play again. What you would want to do is check to see if the background access status that the user has chosen is always allowed or not. Now, if it is always allowed for your particular application, then your app will be able to run for an indefinite period of time, as long as needed, with this unspecified extended execution. If it is set to never allowed or managed by the system, then you will only be given either 0 or up to 10 minutes of time. And so it's really important that you as an app developer have this conversation and awareness of the settings that your users have chosen. Now we also have a set of restricted scenarios. These ones are not actually accepted into the consumer Windows Store, however they are accepted into the Windows Store for Business. Now for enterprise and line of business scenarios, we understand that there are apps that need to run for extended periods of time that may impact a battery-constrained device and drain battery more than what is normally acceptable for a consumer device. And for these, we've enabled the ability for both your background tasks and your foreground applications to run as long as they would need to. So extended background task time will remove the execution time exceeded cancellation reason, as well as the idle violation reason for any background tasks that you may create in your app package. It's still important to check that background access status, because if a user has chosen never allowed, you'll never actually be able to get a background task to trigger. And it's also good to check what the battery saver status is, because that too limits background activity even if you have this extended background task time. You can't have an extended amount of task time if you never are actually able to get your background trigger to activate a task. The second restricted capability is extended execution unconstrained. Now, extended execution unconstrained is used to access a special type of extended execution called the unconstrained type. This uses the extended execution foreground session instead of the previous extended execution session, and you can run while minimized all the way up until standby, until the device goes into a standby situation. And so you don't need to have a battery-aware type of behavior in this case in order to be able to run as long as you need to. Now we've talked about a lot of how you can run from the foreground into the background, but we haven't talked about how you can get activated into the background, and that's all done with triggers. And in this upcoming release, we've added a lot of great capabilities for triggers so that you can allot different resources and enable them to do unique things that you couldn't before. So now you're actually able to create multiple instances of the same background task by adding a new attribute in your manifest supports multiple instances, as well as defining a resource group and adding a background task registration group when you're doing your background task registration with Background Task Builder. And I'll get a little bit more into that in a second. But it's important to realize that background triggers work both in the multiple process model and the single process model. So in the single process model, you're going to be able to use that background activated event. That's an event on core application, or it's an overridden method in a XAML application. Whenever a trigger initiates, then you will receive that callback and be able to start doing work just like you would if it was in the multiple process model. There's no need to create a new separate background task. Your main app process is already doing that background work for you. Once again, it's really important to check that background access status, because background triggers, just like extended execution, are all beholden to what a user has chosen. If a user has chosen that your app cannot run in the background, then you should be aware of that and you should be able to prompt the user accordingly. Now, persistent events are a new feature that we as the platform have enabled you as developers to create. These are really great for framework developers to make the process of doing background activation a lot more simplified for any of your users. As you can see in this little code snippet, what you're going to do with this is you're going to use that background task registration group. And that background task registration group is just added when you use Background Task Builder, and you do all of the normal things that you would do with Background Task Builder: set the entry point, define what the task name is, set the trigger, and then identify that network was requested while you're running, and hit register. One of the great things about this background task registration group is that you're no longer under the background task registration all tasks list. You have your own special list now, such that if, say, the main app developer is trying to enumerate through their background tasks, they won't accidentally step over yours and cause some issues with how your framework or how your particular component within the app works. Now, it's really easy to create these persistent events out of this background task registration group because there is an event called background activated that is actually part of the registration group. All you would do is create an event registration token table in order to map how many different entities have subscribed to your event, and then every time a new trigger comes in, you'll just fire off your own background activated event. So all of this background task registration all gets hidden, and what a user sees, or I should say a separate developer sees, is just what is this event looking like. So all that a user of your framework would have to do is just subscribe to an event, and when that event fires, use those event args, make sure to access the deferral and hold that, and just keep doing work in the background. They don't have to remember all of the registration code. They don't have to access background task registration all tasks to enumerate through those. All they need to do is subscribe to the event that they want in their constructor, and then unsubscribe whenever they want to unregister for that background activation. So with multitasking in the single process model, we've gone over how you can do background media playback, how you can do location tracking, how you can just run your app while minimized in order to do any kind of generic processing, as well as the set of restricted capabilities that enable scenarios for enterprises. We also talked a little bit about background activation and using the background task registration group, and how you can use that to create persistent events that make it a lot easier for anybody else who's taking a look at your code to actually just easily subscribe and unsubscribe to triggers without having to use the background task builder. So with these slides is a set of additional information that provides all links to GitHub samples for everything, as well as tutorials. So go and get creating. Make your new multitasking app with the Fall Creators Update.